Alrighty. Excellent. All right. Good morning. Welcome back. Hope the rest of your day yesterday was good. And that you guys are feeling good this morning. All right. Hopefully you can have your notes available from yesterday. You're probably going to want those as we work through these practice problems today in our activity. We're going to do a Desmos activity today. That will hopefully help us make more sense of our estimating a population proportion, or section 8.2. You will also probably most definitely need some scratch paper, something to write on, something to write with. It does not need to necessarily be in your notes, although it could be, but just something to write on and to write with, because you're going to need to do some math to answer these questions, and it'll be nice to be able to have something to write on. All right, and you'll also want your calculator, although I will have a calculator available in the Desmos activity. So there's that. All right. Alrighty, let's get started. Wait, I want to. No. Edit that one. There. All right. So here we go. If you're still completing the how are you feeling, that's totally fine. That screen is still available. Please finish doing that. And I do know that these are kind of small. I do apologize. I don't know how to make them bigger in the Desmos activity world. Trying to figure it out, but it just doesn't want to cooperate with me. So before we get started, again, these are things that hopefully are in your notes that you already have and that you look at it and say, oh yes, we saw that yesterday. We have conditions for constructing a confidence interval about a proportion. Remember, these are the things that we have to check before constructing a confidence interval. We have our 4-step process for a confidence interval: state, plan, do, and conclude. Our inference method that we learned yesterday, we call this an inference method. The one sample z interval for a population proportion. Okay, and that's using our p hat as the guess for the proportion. And the sample size for desired margin of error, we saw an example of that, where we start with the confidence interval, the percent confidence interval we want, and a maximum margin of error we want. We use that to work backwards to the sample size. All right, so these are some things that we might need today, things, kind of the major parts of our lesson yesterday. And also, if you notice at the top of the student screen, you should have a little calculator here. If you do need a calculator, you can click on that and a little calculator will pop up. I do need to share my screen. That helps me describe what's going on here. All right, so again, if you click the little calculator guy right here, you'll get a little calculator to the right-hand side of your screen. That could be helpful if you need it. You can also go full screen, which doesn't really change the size of anything, unfortunately. All right. So the first 4 questions we're going to have here are multiple choice. However, they do involve work to actually get the answer. You could just guess, and you have a, 1 in 5 chance of getting it correct. However, if you do the math, which is what we're here to do, you have a much better chance of getting it right. So we're going to start. I'm going to open up the first 2 multiple choice questions for you guys to work on. We'll give you, I think we'll start with 7 minutes to work through these problems, these 2 problems. All right. So I'm going to open these up. All right. The first multiple choice question, we have a Gallup poll found that 28% of American adults expect to inherit money or valuable possessions from a relative. Right? The poll's margin of error was plus or minus 3 percentage points at a 95% confidence interval. Interpret this. One of these 5 statements is a proper interpretation of these results. Right? The second multiple choice involves calculation. Right? Most people can roll their tongues, but many can't. The ability to roll the tongue is genetically determined. Suppose we are interested in determining what proportion of students can roll their tongues. We test an SRS of 400 students and find that 317 can roll their tongues. So we do have a sample proportion. We have p hat for this scenario. The margin of error for a 95% confidence interval for the true proportion of tongue rollers, I spelled tongue wrong, among students is closest to one of these 5 values. Right? Again, you could guess and possibly get it right, but I do recommend practicing with the math that we did yesterday. Right? Calculate the margin of error for a 95% confidence interval. Alrighty. So let's talk about these questions. All right, our first multiple choice questions. If you guys want to follow along with what I'm talking about specifically, please go back to the shared screen. If you can follow along while staying on your own screen of Desmos activity, that's totally fine too, just so you know. All right, so our first multiple choice question here. The correct interpretation of what this means from the 5 possible statements, right, is the poll used a method that gets an answer within 3% of the truth about the population 95% of the time. Right. So, because the poll's margin of error being plus or minus 3 percentage points at a 95% confidence level, right? The confidence level is what we're referring to here. And remember, when we talk about confidence level, that means that over many, many repeated samplings of the same size, we would get about 95% of the sampling distributions, right, with a interval. The 95% confidence interval would capture the actual proportion. Right? We have a margin of error plus or minus 3%. Right? The other statements here aren't correct interpretations of a confidence level in this context. Is there anything I can clarify or anything I can explain about any of the incorrect answers as to why they're incorrect? Okay. So if we look at multiple choice number 2, talking about the rolling of the tongues, we have an actual proportion, right? That we get a sample proportion. Let's see. How do I do this? I think. Yeah. It's kind of small though. So let's look at this. Boom. So here's the kind of scratch work that goes with this one. We get a p hat of 317 over 400, and that gives us 0.7925. We have a sample size n of 400. Z star equals 1.96 for a 95% confidence interval. And this is based on what we did yesterday. That's 95% confidence interval happens a lot, so just remembering that the Z star is 1.96 can be helpful. So we get a margin of error that's equal to Z star times the sampling error, or the standard error, sorry. Square root of p hat times 1 minus p hat over n equals 1.96 times the square root of 7.7925 times 0.2075 over 400. We get roughly 0.036. Right. and 0.036 lands us closest to the available option of 0.04. Right? Because of rounding, in this case, we would round up instead of rounding down to 0.03. Is there anything I can clarify about this example? All right. Can't spell. All right. So again, in this case, 0.04 was the closest, right, that we have closest one as far as these options. Okay. So again, hopefully you're doing the scratch work, because that's really what's meant to be happening right now, and you're not just guessing. While you can guess, it is multiple choice. Guessing is fine. You do give yourself an opportunity to be correct if you don't know what to do by guessing. But we want to try and practice the math behind this. Right, so here we go. Let's move to our next set of problems. Right, and once again, guys, it looks like right now I have about 16 people in this activity. And I got like 23 people in the room, 22 people in the room, 23. So I'm missing 7 people, guys. Please, this is your opportunity to practice and get feedback and see how well you're understanding these things. All right, please participate. All right. That being said, we're going to move on to the next 2 multiple choice questions. So I'm going to open those up now. These ones both involve having to do some calculations to get the correct choice in the multiple choice. So again, I do recommend that you do the calculations on some scratch paper. Our multiple choice number 3 here, you want to design a study to estimate the proportion of students at your school who agree with the statement, student government is an effective organization for expressing the needs of students to the administration. You will use a 95% confidence interval, and you would like the margin of error to be 0.05 or less. So we're using the calculation for the sample size. Right? The minimum sample size required is, we have to select what the minimum sample size is. Right? You'll need to use that formula we saw yesterday, the margin of error. Right? This guy here is z star times the square root of p hat times 1 minus p hat over n is less than or equal to margin of error. You'll be able to guess. You'll have to guess a proportion for p hat. You can either use 0.05, or I'm sorry, use 0.5, or if you have another idea based on the context, you could use that, but most likely you're going to use 0.5. And the z star that goes along with a 95% confidence interval. And the margin of error will be replaced with the 0.05 that we want. So you're going to need to rearrange that formula. Right? So that's this one. You'll have to solve for n. Multiple choice number 4. Newspaper reporter asked an SRS of 100 residents in a large city for their opinion on the mayor's job performance using the results from the sample, the C % confidence interval for the proportion of all residents in the city who approve of the mayor's job performance is 0.565 to 0.695. What is the value of C? So based on this interval, we need to work our way backwards to what's the percentage of confidence interval. Right, we know the sample size. We can use the interval to find p hat. We're going to have to do some work on this one. Okay. Alrighty. All right, so excellent. So good news is the majority of you guys who answered these 2 questions got the correct answer. Right, whether you made an educated guess or you did the math, that's good, right? These are the types of questions you'll see on the AP exam. So now, let's talk about the multiple choice number 3. All right, so we'll be on this screen here. we're trying to find the minimum sample size, right? The correct answer ends up being 385, which 9 out of the people who responded said that, so excellent. All right, and if you're looking at the shared screen, here's the work that goes with that. All right, we're going to use 0.5 as the guess for p hat because we don't have any other thing to go off of. We don't have any previous data. They didn't give us an actual p hat, so we'll use that guess. The margin of error that we want is 0.05. The z star is equal to 1.96 for a 95% confidence interval. Right? We're going to use the formula z star times the standard error, square root of p hat times 1 minus p hat over n is less than or equal to the margin of error. But we're going to rearrange this so that we're solving for n. All right, and this is possible. I can do all the steps in the math. We saw the steps yesterday in the example problem. I just didn't rewrite it as a formula, but we can still do that. So we'll use n is greater than or equal to z star times square root of p hat times 1 minus p hat divided by margin of error, all squared. So we'll put in all the values we have, right? And we get 384.16. Because n must be larger than, greater than, or equal to 384.16, we will round up to 385. We cannot round down in this case, even though we're closer to 384. Rounding down is not an option because of that greater than or equal to sign. So, anything I can clarify? Yes, Stephanie.
So I didn't rewrite the formula that n is greater than, and that one I did it how you would normally do it. If
that's fine.
Oh, okay. So does it matter?
Yeah. No, this is just no. It doesn't matter. Okay. Because I'm more familiar with the mathematics and everything, I prefer to do it this way because it makes sense to me. That's an extra step though, so to say, right? Using the formula the way that it is provided, the way that we have it in our notes is perfectly perfect, right? You don't need to rearrange the formula. I do that because I like doing it that way. And I want to give you guys these options like, hey, we can also do this. This is another method, so to say. There's never going to be only one way to set up and solve something for the most part. You can rearrange things, you can do it in a way that makes sense, but you need to be clear about how you're doing it, right? So I always show the formula I'm going to use in its general form without my numbers, right? I've identified all my variables. I'm showing the formula, right? Those are things that I do, so it's very clear about what I'm doing. Those are the important parts of your formula writing. Is it clear? Does it make sense? Whether or not you rewrite the formula so that you can do it in a different manner, doesn't matter. That was a very long explanation, but
Thank you.
You're welcome. Any other questions or anything else I can clarify?
Can you explain where you got the z-score?
Yeah, so the z star right here, we're told for this question that we want we want a 95% confidence interval, right? Or that we have a 95% confidence interval. We want a 95% confidence interval with a margin of error no greater than 0.05. The 95% confidence interval, right? We know that the 95% of our data resides within that middle portion under the curve of our standard normal curve between two standard deviations, as our 68, 95, 99, 7 rule said. we learned yesterday that 1.96 is a closer approximation for the 95%. We find this on table A. When we open up a copy of table A. Yeah, that'll work. I have just like a little portion of table A here. So with a 95% confidence interval, I have 2.5% on each tail, right? So on table A, I look on the interior for 0.025, which is 2.5%, right? We get exactly 0.025. Sorry, where'd it go? Right here, right? And that corresponds with the negative 1.9, right? And the 0.06, right? So that gives us negative 1.96. We'd have positive 1.96 on the other side of table A if we found 0.975 on the right-hand side of table A. We're using the negative value because the negative value gives us the actual percentage of the sides. Did that answer your question?
Yeah, it did. I think I just needed to see it like again. So
yeah,
thank you.
Of course. You're welcome. All right. Anything else I can clarify? So again, we get the minimum sample size of 385. Right. So now we'll go to the next multiple choice question. Oh, sorry, Matthew, you have a question?
So, Mr. Mosley, does it matter what kind of formula do we use? Because I don't know, like, well, the formula is kind of similar that I use, but somehow I was able to get the answer. Is there like different get the answer, or is there like actually a specific one?
Well, so the formula we have that we've been provided for, essentially from the textbook and everything, is this z star times the standard error less than or equal to margin of error, right? Where z star is our critical value. This is what we've been given as far as like, hey, we can use this when dealing with margins of error. The reality is, we can kind of manipulate and use any part of this to find other parts, depending on the information we have. Let me think of a way to show this that's not going to be terribly confusing. Let's look here. So okay. So our general like way to find an interval, because we're talking about confidence intervals overall, right, is we find the interval by taking our statistic, then adding or subtracting critical value times the standard deviation of the statistic. Right? This is our general kind of idea for finding our interval. Now, in this section, the statistic is p hat, plus or minus is there. Critical value is Z star. And the standard deviation of a statistic is called the standard error. Which we can denote as SE, or we can use SP hat. Now, standard error is that part of the formula, right? And Z star is found using table A. So in the example, we have the margin of error, right? The margin of error right? The margin of error is that part to the right of the plus or minus, that entire thing, Z star times standard error. And so that's where the formula comes from, right? Depending on what pieces of information I have or what pieces are missing, I can manipulate this formula to do what I need to do or find what I need to find. The formula we used in this multiple choice question is the most convenient formula to use because it zooms in right on the margin of error, which is something we want, and that's what we're focusing on in this case. If you did it in a different method and you got the right result, that's good. I would try that method with a different problem and see if it works again, because sometimes it just happens to work and it doesn't always work. The formulas provided like from the textbook and from class, those are the ones that are shown to work over and over again. So we want to use those more consistently. But if you find another method and it consistently works, use it. And that again was a really long explanation. I apologize, but
No, you're good. I understand. Thank you.
Cool. You're welcome. All right. So now let's look over to the fourth question here. With the newspaper reporter with an SRS of 100 residents in a large city, we're trying to find what is the percentage of confidence interval. What's the value of C? All right. Now we get the actual solution is 82. And again, we have our work for that. It's a little bit more work. We know that the confidence interval is 0.565 to 0.695. We know the sample size. We do not know Z star yet because we need the confident in the percent or some other math done before we can get there. So we start by finding P hat because I have the interval. All right, so P hat is the midpoint between the two sides of the interval. So we do 0.565 plus 0.695 divided by 2, we get 0.63. That's P hat. Right, now we have more stuff to work with. Because of what we just talked about down here, right, I can find the margin of error. Right, so the margin of error is 0.63 minus, and I'm doing the minus the larger side, the smaller side. So we get 0.63 minus 0.565, and I get a margin of error of 0.065. We can confirm this by adding 0.065 to 0.63 and confirming that we get 0.695, which we do. Right, so we have a margin of error now, and we have P hat. Right, that means I can use that same formula, right, or a variation on the formula, because in this case we're using equal instead of a inequality, less than or equal to or greater than or equal to. Because again, I know that Z star times standard error equals margin of error. I have everything I need to find standard error. I have P hat and I have N. I know what the margin of error is. I can solve for Z star. And so that's what we do here. Margin of error equals Z star times the square root of p hat times 1 minus p hat over n. So we get 0.065, replace me with its value, equals z star times the square root of 0.63 times 0.37 over 100. We divide both sides by the square root thing, and we get z star equals 0.065 divided by the square root of 0.63 times 0.37 divided by 100, and that gets us 1.35. We then find the z-score on table A of negative 1.35, because that'll give us the proportion that is left on the two tails when we look at the negative z-score. Right, on table A, and I closed that. So when we do that, right, the proportion less than negative 1.35 on the standard normal curve from table A is 0.0885. So that means that 0.0885 is only one tail. So I multiply it by 2 to get how much percentage is in both tails. I get 0.177 is the proportion between the two tails. Subtract that from 1, and I get 0.823, which means the middle proportion left, right, excluding the two tails, is about 0.823. So C is about 82, or we have an 82% confidence interval. So again, this kind of speaks to what Matthew had brought up in his question. We sometimes just need to manipulate the equations and formulas we're given to find the thing we need. In this case, we needed to find z star to work our way back to the percentage. Okay. What can I clarify about this one?
What is the two tail of leftovers? What does that mean?
So when let me find a picture here that'll work for this. So when we're finding our percent interval, like our confidence interval percentage, that percentage is the center percentage within our curve, within our distribution, right? So on either side of that central part, we have the tails that contain the area that's excluded, right, from our interval. Let's see, I think, yeah. All right, so this kind of shows that. So this is for a 95% confidence interval, right? So we're capturing the central 95% of the distribution, leaving area in both of the tails that is excluded, right? When I find the z-score based on the negative when I find the z-score of negative 1.35 on table A and trace it to the interior for the proportion to the left of that value, that gives me, I zoomed out again. That gives me the shaded area to the left of that z-score, which in that case, our case was 0.0885. Yeah, I don't have that part of the table in this picture. So that's why, and so the value I found is only for the area in one tail, the one to the left. So I double it to get the area between the two tails because they have the same area because of symmetry. So doubling it gives me the total amount of proportion from the curve that is excluded from the central part that I want. Did that answer your question?
Yes. Okay.
Sweet.
Thank you.
All right. You're welcome. All right. Anything else I can clarify? All right. Let's see. All right. We're going to move on to our next question. This one's going to be a little different. I'm trying something new. And again, I apologize for how small the picture is. I can't make it bigger. So if you have your own copy of Table A, you're welcome to use it. But we have the portion you need provided here. So we're going to find a Z star for a 93% confidence interval using Table A. Right. Sketch on a copy of Table A showing the proportion to the left of the Z-score that corresponds with 93% confidence interval. All right. So this goes back to exactly what Stephanie had asked about the two tails. Right. If I'm capturing the middle 93%, how much is left? That leaves us with 7%. That must be split equally between the two tails. So we cut 7% in half, right? We get 3.5% as a decimal, right? So we convert 3.5% to a decimal. We find that decimal on the interior of Table A and trace it to the left and top part of Z and put those together to get our Z star. Remember, Z star will always be a positive number. So even though we're on the negative Z scores here, you just take the positive. So let's look at this guy. So what you should have found using Table A, or hopefully what you're getting close to finding, was that the Z star has a value of 1.81. Okay, we find this right using Table A and a couple other things. So we have 93% confidence, right? So 1 minus 0.93 gives us the 0.07. 0.07 divided by 2 gives us a 0.035. That's what we're looking for, right, on Table A. This, because I can only look for one tail at a time, so to say. So I'm going to choose the one that's going to be on the left-hand side because it gives me what I need. It's easier to find. So we're looking for 0.035. We have 0.035. The closest we get to 0.035 is going to be here at 0.0351. Right, the other values next to that are not any closer to 0.035 than that one, so that's what we're going to use. Right. So, right, that follows back to negative 1.8. And goes up to 0.01. So this leaves us with a Z-score, negative 1.81, which gives us a Z star of 1.81. Because then we're using the positive value. Z star is always positive. Is there anything I can clarify? All right, we're going to stop here because we're at about an hour and 15 minutes. I don't want to, there's a few more problems on here, and I'll open this up so you guys can continue to work through this if you want to do those practice problems. Even if you don't want to enter them into like Desmos, or you just want to see the problems, you're welcome to do that. So I'll open up this activity in just a minute. Excellent. Is there any other questions? Anything else I can clarify before we wrap up here? Okay. One last thing. So I do have the section 8.2 practice problems available in Canvas in our resources. So if you'd like to take a look at those, please do. And we will be going into section 8.3 on estimating a population mean next week. Right. If you do have any questions, please let me know. Other than that, have a great rest of your week, and I'll see you guys on Tuesday next week.